The universe has no sound, but it has scars. This is the most extreme event ever recorded in physics. Two of the most powerful entities in the cosmos do not simply collide. They clash like two open wounds in reality itself. And when two shadows touch, it is not a peaceful union. It is a cosmic execution. An object weighing 1 billion suns is cast out from its own galaxy, not by choice, but by a recoil from the hands of the laws of nature. Traveling at 1.1 million kilometers per hour, it hurtles into the void. Now, we witness every stage of what actually happens when reality tears itself apart. After a million-year approach, they do not collide immediately. They can't. Instead, they begin the binary death spiral. With every orbit, they warp the very fabric of space-time, bleeding out tiny amounts of energy as gravitational waves. Think of a stone dropped into still water, except the water is not water. It is the geometry of space itself. Each ripple carries energy away, causing the orbit to tighten. At first, this inward drift is almost imperceptible. But as they draw closer, the feedback loop takes hold and the spiral accelerates toward the inevitable. At the Max Planck Institute for Gravitational Physics, supercomputer simulations reveal this as a feedback loop with no exit. The closer they get, the faster they orbit. The faster they orbit, the more energy bleeds away. The more energy bleeds away, the closer they get. And this process, this slow, inevitable tightening, can last for millions of years. Sometimes billions. Here is a way to feel that number. Every human civilization ever built spans less than 12,000 years. Two black holes can spiral together for a duration so vast that the entire story of human existence would not register as a single heartbeat on the timeline. And from the outside, through all of those billions of years, you would see almost nothing. Just two dark points, circling. How many such pairs are out there right now, millions of years from their end, with no one watching? As the two black holes enter the final seconds of their death spiral, they become the ultimate architects of distortion. Moving at near light speeds, they begin a brutal visual game with the cosmos. Recall the year 1919, when the world first confirmed Einstein's relativity during a solar eclipse. We saw starlight bent by the sun, but here, at the heart of this tragedy, that gravitational lensing is pushed to a state of frenzy. Each black hole seizes the light from billions of distant galaxies, magnifying and whipping them into a halo so brilliant it borders on blinding. In their final moments, the two darkest, most desolate entities in the universe are surrounded by the most violent light show ever recorded. Yet, amidst that chaos, within the collapsing space between them, something else is silently unfolding. Something so devastating that almost no one dares to speak of it. At the boundary where these two gargantuan gravitational fields intertwine, space and time do not merely bend. They begin to tear in ways that have no precedent in nature. This is where closed, time-like curves emerge. Fractures in the geometry of reality where space curls back upon itself into infinite loops. Imagine a single photon, a grain of light, imprisoned within such a loop. It is forced to experience the same moment over and over, billions of times, right in the eye of the collision storm. In physics, we call this a remarkable phenomenon, but in reality, it is the closest thing to an eternal prison. One moment, frozen and repeated forever, until reality itself collapses and shatters the walls of that loop. Black hole collisions do not happen in silent darkness. They crash into one another amidst light borrowed from a billion galaxies, and a timeline that has already been shattered. When the two event horizons finally touch, the merger takes less than a second, less than a blink. The energy released as gravitational waves equals roughly 3 solar masses, converted into pure ripples in the geometry of space. Our sun will convert about 0.7% of its mass into energy across its entire 10 billion-year lifetime. A black hole merger converts 3 entire suns' worth of mass in under a second. That is not a metaphor. That is the arithmetic. And here is something the engineers at JPL understand viscerally, because they watched a smaller version at Jupiter in 1994. When comet Shoemaker-Levy 9 struck Jupiter, each impact left bruises in the Jovian atmosphere the size of entire continents, visible from Earth for months. A black hole merger releases more energy in its first millisecond than that entire event. All of it is released not as light or heat, but as pure distortion of space, invisible to every telescope ever built. The most violent event in the universe happens in silence. Now here is the detail that keeps the men and women at the Perimeter Institute for Theoretical Physics in Waterloo awake at night. The no-hair theorem tells us a black hole can be described by just 3 numbers: its mass, its spin, and its electric charge. No memory of the stars that built it. No record of what fell across billions of years. A black hole consumes everything and remembers nothing. So when two collide, and all of that history reshuffles into one new entity, where did the information go? Is it deleted or encoded in the gravitational waves, waiting in a language we cannot yet read? The universe has refused to answer. The newly formed black hole does not simply settle, it rings. The researchers at the Albert Einstein Institute in Potsdam call this ring down. Their analogy is a bell. Strike one, and it vibrates at a mixture of frequencies, the loudest fading first, the quiet harmonics lingering. A merged black hole does the same, except what vibrates is the curvature of space-time itself, in frequencies called quasi-normal modes that decay over milliseconds. And then comes the recoil. This is the detail every popular account leaves out. Because the two black holes were almost certainly not matched in mass, the gravitational waves radiated in each direction carry slightly different amounts of momentum. Momentum is conserved. The newly born black hole gets kicked. The numerical relativity team at the University of Maryland has mapped this effect, and their simulations show that for the right combination of mass and spin, the recoil can reach several thousand kilometers per second. The escape velocity of the Milky Way is roughly 550 kilometers per second. A black hole containing 100 solar masses gets ejected from its home galaxy by the asymmetry of its own birth. That is a big coincidence of scale. The universe seems almost cruel in producing the most massive objects physics allows, forged in its most violent event, launched as permanent exiles into the void between the galaxies. They drift outward forever, each one containing the compressed and forgotten history of millions of swallowed stars, in a darkness so complete that no telescope can confirm they are there. That is what the equations say. We are living in a historic moment. For the entirety of human history until September the 14th, 2015, every piece of information we had about the cosmos arrived as light. From ancient star charts to the X-ray maps built by Chandra, it all came as photons, but gravitational waves passed through gas clouds and galaxies and the solid body of the Earth, as if none of those things exist. The engineers at LIGO built a machine that must detect a change smaller than 1,000th the diameter of a proton. They did it. And when they heard that first chirp from two black holes merging 1.3 billion light-years away, they opened a door sealed for all of previous science. Not a better pair of eyes, a new sense entirely. Space is hard. These events do not care about our desire for clean answers. But every detection is another sentence in a story running since before our sun existed. Everything you know is wrong, because there is always more to know. Black holes are not where things end. They are where the universe asks its hardest questions. And we are the first species in the history of this pale blue dot, with ears sensitive enough to hear them.